Good afternoon to all of those in Central Europe, and also good evening and good morning to colleagues joining from other time zones. My name is Noah Mayhew. I am a senior research associate at the Vienna Center for Disarmament and Non-Proliferation, and it's my great pleasure to moderate our webinar today on nuclear-powered submarines and non-proliferation. The subject of naval nuclear propulsion has become quite salient in recent years, especially in the context of non-nuclear weapon states' increasing interest in developing their own naval nuclear propulsion programs. As many of you would know, non-nuclear weapon states parties to the Treaty on the Non-Proliferation of Nuclear Weapons are required to conclude safeguards agreements with the International Atomic Energy Agency that provide credible assurance that nuclear material is not being diverted. While the NPT prohibits military explosive uses of nuclear technology, it does not prohibit non-explosive military uses. Here enters a provision, Article 14 of most countries' safeguards agreements, Article 13 in one case, that allows for the non-application of routine safeguards measures when nuclear material in question is in the non-prohibited, non-explosive military use. In this case, nuclear-powered submarines. What does an arrangement under Article 14 look like? Well, we don't know, as no non-nuclear weapon state has to date concluded one. And this is going to be the discussion of the subject of our discussion today. At this point, I will introduce our speaker for today's webinar, Mr. Alexander Hoppenbrouwers. We had the great pleasure to have Alexander work with us as a research intern, where he conducted an excellent study on the technical considerations that would be important for determining what an Article 14 arrangement would look like. We will hear the results of Alexander's research, which will be published on our website in the coming weeks, and its implications for Article 14 arrangements under countries' safeguards agreements. We will then turn to Laura Rockwood, a senior fellow here at the VCDNP, a former senior official in the IAEA's Office of Legal Affairs, and, if I may say, the Queen of Safeguards. And Laura will comment on the research itself and what her thoughts are on the issue as it stands today. At that point, we will move into the question and answer portion of our webinar. And on this note, a few sort of housekeeping comments. First, if you do have questions for either Alexander or Laura, please use the Q&A function in Zoom, which you will find at the bottom of your screens. You can raise your hand if you wish, but we will be doing the actual questions through the Q&A function. Second, please note that this webinar is being recorded. Third, and importantly, I would be remiss if I did not give our heartfelt thanks to the Carnegie Corporation of New York for the generous support that, among other things, makes our series of seminars and webinars possible. Now, so that's enough of me talking. I invite Alexander to take the floor for your remarks.
Yeah, thank you very much, Noah, and of course, thanks to everybody also for coming to the webinar. I'll share my screen now. So, as Noah mentioned, the topic of my research at the VCDNP was Article 14 arrangement, which have, of course, been gaining increasing attention with the nuclear powered submarine programs being launched by various non-nuclear weapon states. And in this context, I looked specifically at technical factors. So I'll try to spend as little time as possible on discussions of legal or political considerations. I'll need to touch on them every now and then, but the main focus is really the technical specifications. I'll give an abridged version of my research, meaning that I'll skip over a few factors that I researched that didn't seem to have a major impact on an Article 14 arrangement, and I'll also summarize. So please do feel free to ask questions about topics that I haven't touched on as much, or topics that you'd like to see me go into a bit more depth about. So to provide a bit more of the basic background information that we need to tackle this subject, first of all, it's important to note that nuclear-powered submarines are different from nuclear-armed submarines. Nuclear-powered submarines, the topic of our discussion today, only use nuclear reactors to propel themselves, but they're not actually armed with nuclear explosives. And this is also known as naval nuclear propulsion. Now, naval nuclear propulsion doesn't fall under a military explosive use, which is a prescribed military use under the Treaty on Non-Proliferation, but it also doesn't fall under peaceful uses, since after all, they are military submarines. So this means that non-nuclear weapon states are allowed to make use of naval nuclear propulsion, but at the same time, routine safeguards measures, the measures taken by the IAEA that aim to verify that nuclear material is not diverted towards nuclear explosive devices, cannot be normally applied because there are classification concerns related to the military activities, and simply said, underwater operations mean that different inspection parameters are needed. However, some means of verifying that nuclear material is not diverted are, of course, still necessary. And this is where a so-called Article 14 arrangement comes in. What we call Article 14 is based on paragraph 14 of INFCIRC 153, which is a text negotiated by NPT member states. And this text, this document, is used as the basis for negotiating comprehensive safeguards agreements, which are agreements between states and the IAEA that set out routine safeguards measures in each state. An article based on paragraph 14 is an absolute standard part of different comprehensive safeguards agreements, and the text of paragraph 14, including its number, is almost always unchanged in the different CSAs. And we derive the name from the fact that it is still included as the 14th article of most CSAs. This article and this paragraph provides for the temporary non-application of routine safeguards measures to nuclear material in non-prescribed military activities. So this is where we get our first question, which is, of course, where does paragraph 14 exactly apply, and in what way does it apply? For that, we have to ask, what is a non-prescribed military use? So on the screen, we see an image of the nuclear fuel cycle. And depending on the level of enrichment of fuel used in naval nuclear propulsion programs, the fuel cycle of these programs is similar to that of the production of nuclear material for a weapons program until sometime during or after the enrichment stage, which you see on the left side of the image. So states making an Article 14 arrangement could try to argue that some parts of this fuel cycle qualify to not be put under routine safeguards because they're part of a non-prescribed military activity, the Naval Nuclear Propulsion Program. And if this results in inadequate oversight, there could be opportunities to divert nuclear material. But what's crucial to note here is that the negotiating history of INFCIRC 153 sets certain bounds. There was an understanding during the negotiations that activities like enrichment and reprocessing would not qualify for the non-application of routine safeguards. And the main activity that the negotiating history is a bit more unclear about is fuel fabrication, which you see at the top right. So the non-prescribed military activity and related to it, the non-application of routine safeguards measures would start sometime during or after fuel fabrication in the top right, and it would end somewhere before reprocessing or disposal in the bottom right. So the second question that then comes up is, what are the most important differences in a paragraph 14 approach that stem from different given technical factors? To answer that, we have to see the implications of these technical factors for first, diversion, and two, verification, because these are the two challenges that any Article 14 arrangement is concerned with, making sure that the material cannot be diverted and making sure that the IAEA can actually check that this isn't happening. To start off with, it's important to know that the technical factors that are important for paragraph 14 always depend on specific classification issues of the naval nuclear propulsion program, because classification determines what we can verify and how we can verify it. So just to give an example, we won't be able to implement verification measures inside of a submarine if we can't enter the submarine because of classification concerns. And spoiler alert, we likely won't be able to enter a submarine. Um, then the first technical factor that I looked at was the type of fuel that was used in naval nuclear propulsion programs. Now, all naval nuclear propulsion programs use uranium as fuel, and the first specification in which they differ is the level of enrichment of uranium. And enrichment, of course, refers to the percentage of the total nuclear material that is actually fissile. Higher enrichment first means that less or no further enrichment is needed before the material is enriched enough to be used for the production of nuclear material for a weapons program, because high levels of enrichment are needed for such programs. Higher enrichment also means that generally less refueling is needed, and we'll discuss some implications of refueling later on. Lower enrichment, on the other hand, means that spent fuel contains more plutonium. So in that case, reprocessing or disposal poses additional diversion risks. A second relevant specification of fuel type is the actual design of the fuel elements. Now, in naval nuclear propulsion fuel, nuclear material is embedded in ceramic and or metallic matrices before it's put into the reactor. And a fully metallic matrix actually makes it a bit easier to divert this material because it can be the metallic matrix can be separated from uranium with a relatively straightforward chemical process when compared to ceramics. So a ceramic matrix generally makes diversion harder. Uh, and the fuel design also has implications for our ability to verify certain information. First of all, for instance, we can ask if standard verification equipment actually fits into or over different fuel elements. Um, and we have to ask what the level of classification about what the fuel elements look like is, because potentially we might not be able to visually verify the presence of certain fuel elements. Then the next factor is the domestic nuclear infrastructure of the naval nuclear propulsion state in question. And again, we see an image of the full fuel cycle. The first way in which the fuel cycle in the state in question has an impact on Article 14 arrangement is that it impacts fuel acquisition. If a non-nuclear weapon state cannot produce its own fuel, then paragraph 14 might be faced with challenges of dealing with international transfers, for instance, making sure that verification measures can be applied in a satisfactory way during or after such transfers, even if one of the parties in that transfer is a state without routine safeguards obligations. On the other hand, if the naval nuclear propulsion state does produce its own fuel, then paragraph 14 is faced with a whole different set of challenges from having to deal with a fully domestic nuclear fuel cycle and the associated diversion risks that come with this cycle. It also impacts what we call nuclear latency, or the ability of a state to very quickly set up and fulfill a weapons program. Developing nuclear infrastructure to meet the demands of a naval nuclear propulsion program or building up storage of naval nuclear propulsion fuel can also bring increased capacities when it comes to the production of a nuclear material for a weapons program and therefore brings increased nuclear latency. As explained before, it's important to know what parts of the naval nuclear propulsion fuel cycle routine safeguards are applied to, and what verification measures are possible where these routine safeguards are not applied. So fuel fabrication or initial storage in spent fuel pools could see a partial non-application of routine safeguards. So we have to ask what characteristics of the nuclear material entering and exiting fuel fabrication facilities can we measure? Are we allowed to inspect fuel fabrication facilities when they're not being used? And all of these will affect our ability to verify a lack of diversion during the fuel cycle. The next factor is military infrastructure. And in this context, classification concerns partially determine the level of access that can be granted to IAEA personnel. What's especially important to be able to do in military facilities is being able to observe refueling activities when the nuclear material is actually being put into the submarine. The relevance of many of the other factors that we'll be discussing today depends on being able to tell whether or not the nuclear material is actually in use powering the submarine's reactor, and this is, of course, the most effective way to verify that. We can also think about the possibility of covert military bases, nuclear material potentially being diverted out of sight of satellites in a bit of a James Bond-esque scenario. But my research suggested that really the time and effort to set up such hidden bases is not worth it, especially because they don't address other means of gathering intelligence, for instance, human or signal intelligence. So it's unlikely that this will be a realistic scenario. Then, what's relevant to both of these past topics, both military and nuclear infrastructure, is the potential for design choices that can facilitate verification. These choices could include things like very clearly separating naval nuclear propulsion related areas from other areas to reduce the exposure of IAEA personnel conducting verification activities to classified information unrelated to the naval nuclear propulsion program, and then trying to maximize the access of this IAEA personnel to the areas related to the program. This could include things like having a single point of access to any area related to the naval nuclear propulsion program, and then allowing the IAEA to track anything entering and exiting this single point of access. However, as with other issues that we'll tackle today, we can't assume that a state is going to prioritize IAEA verification over the other needs of its naval nuclear propulsion program. And it's likely that the IAEA will be dealing with a relatively low level of access to naval nuclear propulsion related infrastructure. The next factor is the design of different submarines. And here there's really one word that you need to remember, which is hatches. Does the submarine have a hatch that provides access to the reactor? Hatches are mostly used in submarines that are fueled by low enriched uranium, because in these, generally, refueling is more frequently necessary. And having a hatch above the reactor compartment means there is no need to cut into the hull to reach the nuclear reactor, which reduces the time it takes to get to the nuclear material, which reduces refueling time from usually months or years to just a bit over a week in some cases, of course, depending on other circumstances as well. This also means that in addition to the refueling time, the diversion timeline for a submarine with a hatch is also far shorter. So on the screen, we can see the French Submarine class with a hatch on top and the American Los Angeles class without a hatch at the bottom. In addition to hatches, I looked at a number of other submarine design choices, such as the type of metal that's used in the hull, the internal layout of the submarine, but all of these will most likely have a negligible impact, especially compared to hatches. But again, I'm happy to take on any questions that anybody may have. Then the next factor is the design of the engine and the nuclear reactor in the submarine. Different designs of the engine and reactor can make it harder or easier to access the nuclear material. For instance, if you use liquid metal to cool your reactor, it could make it harder to safely and quickly remove nuclear material compared to using pressurized water, which is what's used in most nuclear-powered submarine reactors. What's important to know here is that usually nuclear material is accessed through the top of the submarine. And by accessing through the top of the submarine, there is, for instance, less radiation shielding material blocking your access to the nuclear material. So a lot of potential obstacles are actually smaller than one might initially assume, because we avoid a lot of them by going through the top. Still, different designs can impact the timeline of removing the nuclear material. For instance, if you physically separate turbines and generators from the reactor core, you could reduce diversion risks by having less access points to the reactor. Another topic that's been increasingly discussed lately has been sealed reactors. So using welded shut power units inside of your nuclear reactor that are designed specifically to reduce the access to nuclear material. And this could be a major barrier to diversion because you have to get through an extra layer of obstacles, and this could provide more confidence in Article 14 arrangement. The question is, of course, to what extent can we prevent access to the reactor core, to the nuclear material, while we still respect concerns like nuclear safety? So it remains to be seen how exactly this could be implemented and the exact impact that this measure could have on an Article 14 arrangement. Then the most effective way of confirming the presence of nuclear material on board of a submarine in order to verify a lack of diversion is, of course, simply measuring the presence of nuclear materials in the submarine. Recently, several techniques have been developed that would allow this to be done from nearby, but not necessarily inside the submarine. There is some discussion about how feasible these techniques are, but for the purposes of our discussion, we'll assume that we can actually verify the nuclear material from outside of the submarine. And these measurements would be carried out between different periods of operational use. And the reason I use this term operational use is because the time where the most minimal verification measures would be applied, where we're guaranteed to have also a non-prescribed military activity. Nobody would refute that during operational use, the material is in a non-prescribed military activity. And this operational use could either be understood as the time between refueling of the nuclear submarine or the time between different returns to port of the submarine. So when it's actually at sea. Refueling happens far too infrequently to really have a relevance for diversion scenarios. This is a timeline of several years, also in low enriched uranium submarines, whereas timely detection of diversion would be several months. However, returns to port usually happen about every 3 months or so, and that gives us a relevant timeline for verification. So making the somewhat big assumption that we can measure the presence of nuclear material on board of the submarine when it returns to port, and the state in question grants us permission to do so, two main factors would affect the relevance. First, this is what is the average and longest patrol time of the submarines in question. This is affected by resupply needs and crew rotation, and will be affected, for instance, by whether the submarine can be partially resupplied at sea, as we can see on the picture. At sea resupply never fully replaces resupplying at port, but it could still have an impact. And second would be what ports does the submarine actually return to? Because, of course, a foreign state that houses a nuclear submarine for resupply purposes wouldn't necessarily agree to having IAEA personnel on its military bases, especially if it itself doesn't have routine safeguards obligations or doesn't have an Article 14 arrangement in place. But generally speaking, a shorter time between being able to confirm the presence of the nuclear material in the submarine gives the IAEA more confidence in the Article 14 arrangement in question. Then the third question that comes up is what can the technical factors that we've looked at tell us about diversion risks? The first point to make here is that covert diversion is not very likely to happen when the fuel is being used to power the submarine. There are a large amount of obstacles to physical extraction of the material during the use of this material in the boat itself. One example on the screen here is the solid metal hull of the US Trident, an Ohio-class submarine in the picture. If you don't have a hatch for fuel extraction, you need to cut through this entire metal hull with heavy equipment, and that sort of operation is going to be noticed by other states, for instance, through satellite imagery. Another important point is that naval nuclear propulsion fuel is not the same as material that's directly suitable for use in a weapons program. So the fuel elements used in a nuclear-powered submarine would need to undergo very specific chemical reprocessing before they will be useful to a weapons program. And this reprocessing is even more difficult if you use nuclear fuel that uses ceramic matrices, for instance. Then another point is that when the reactor is turned on, the nuclear material increasingly becomes more and more radioactive throughout its operations. And that makes it far harder to handle and makes diversion a lot easier when it's not yet as radioactive. Now, using an excuse to remove nuclear fuel from the submarine, trying to avoid international attention to the extent possible, for instance, lying about the reason why a submarine is spending a lot of time at port, could theoretically give a head start to a weapons program, but generally, it's not very likely that fuel is diverted between refueling, either covertly or with such an excuse. Then the second point is that, of course, diversion could occur at other points of the naval nuclear propulsion fuel cycle. The non-application of routine safeguards can offer opportunities for diversion, depending on what verification measures replace these routine safeguards. And the relevance of this point depends entirely on what the fuel cycle looks like. For instance, are we dealing with a fully domestic naval nuclear propulsion fuel cycle where parts are not subject to routine safeguards due to an Article 14 arrangement? Or, for instance, is there an opportunity to extract plutonium during reprocessing activities if we're dealing with a low enriched uranium program? And a crucial question here is the level of enrichment of the nuclear material. And my own assessment through this research was that one of the main concerns for diversion risk is highly enriched uranium in fuel fabrication facilities where routine safeguards are not applied and where they're not replaced with adequate alternative verification mechanisms. Then the third point is the naval nuclear propulsion's program's impact on nuclear latency. There is a risk that a naval nuclear propulsion program becomes a reason to develop a state's nuclear latency, to build up a reserve of nuclear material, especially that's not yet converted into naval nuclear propulsion fuel, and therefore we don't have to go through all the reprocessing activities. And this could benefit a breakout scenario, potentially. Um, the potential success of diversion also depends on the state's capacity to transform their nuclear material into something that could be used for a nuclear weapons program after they've diverted it. And this requires specialized facilities, specialized knowledge, meaning that the more of those a state has, the greater the risk that diversion can actually end up in the production of nuclear material for a weapons program. And of course, these concerns only come up if the production of naval nuclear propulsion fuel is mostly, or in certain key parts, domestic. And what's also important to know, of course, these concerns aren't necessarily specific to paragraph 14, because as we explained before, enrichment would not be subject to Article 14. It would stay under routine safeguards measures. So most of these are not Article 14 concerns. They are general concerns that Article 14 could also play a role in. Then the fourth and final question is what are some real life implications of these findings? And in fact, we see a very major difference in the technical specifications of different naval nuclear propulsion programs. And we see an associated difference in what design of an Article 14 arrangement would seem most appropriate to meet the unique challenges of each program. First, we see different submarine designs and fuel that these submarines rely on. Looking at real-world past and present efforts to acquire nuclear-powered submarines, we've seen interest in submarines with and without hatches, using uranium enriched to less than 10 and more than 90%. Submarines that were designed to not require refueling during their entire lifetime, or submarines that are designed to facilitate refueling activities, submarines that use welded shut power units or more accessible versions, etc., etc., etc. Also, when it comes to industrial and nuclear capacities, we've seen states express an interest in naval nuclear propulsion programs when they don't have, when the only part of the actual fuel cycle happening in that state would be the storage of spent fuel. But we've also seen states express an interest when they can actually have a completely domestic fuel production cycle. So this means that any Article 14 arrangement will need to be designed with the specifics of each case in mind in order to maximize its effectiveness. For instance, two Article 14 arrangement might differ in that one focuses on clarifying what parts of the fuel cycle routine safeguards are and aren't applied to, when another might be more concerned with making sure that the international transfer of nuclear material between states with different safeguards obligation goes well. It could be confirming the presence of nuclear material on the submarine through frequent inspections versus observing refueling activities and make sure there are high barriers to nuclear materials extraction, etc., etc. So, thank you very much for your attention. Please do feel free to ask any questions you may have. I know that quite a few may have come up, but thank you again, and I'll pass it on to Laura for now.
Uh, Thank you, Alexander, very much. And Laura, over to you.
Great. Well, first of all, thank you for the invitation, and thank you to Alexander for addressing some of the issues which I don't think the general public has been exposed to since this issue came about, or let's say, since it became a significant issue within the last year or two. The importance of your presentation is to emphasize that there are these safeguards questions are technical, highly technical, and so are the answers to them. And any Article 14, Paragraph 14 arrangement will have to be specifically tailored, keeping in mind the very factors that you've articulated during your presentation. And one of the other factors that's really important, and you've emphasized this as well, is the legal obligation the IAEA has to protect classified information. Now, one of the challenges that you didn't mention, but will come up, is that states consider different information, different types of information classified. So there's no, let's say, global definition of what constitutes classified information. And if you had a state that ran a submarine and they didn't consider it classified, no problems there. A couple of points that I wanted to add to. One is we frequently interchangeably use the words peaceful, non-peaceful, military. When 153 was negotiated, the phrase that's in the title of paragraph 14 is uses in military, non-prescribed military activities. So paragraph 14 only applies to non-prescribed military nuclear activities. So paragraph 14 wouldn't be an appropriate provision to invoke in the event that you had a civilian propulsion program. And indeed, in the past, there have been a couple of efforts, once in Germany and once in Japan, to use nuclear for civilian propulsion. Paragraph 14 wouldn't have been relevant and wouldn't be relevant today. But also, what's interesting is the difference between military versus non-peaceful. If you look at the Tlatelolco Treaty, and I mention this because Brazil is one of the countries that has invoked their Article 13, which corresponds to 14. Tlatelolco Treaty requires the states to commit themselves to peaceful uses of nuclear energy. And their position is that propulsion is not inherently non-peaceful. Okay, and I think if you look at the language, both of the Tlatelolco Treaty and the Rarotonga Treaty, relevant to Australia, both of them contain a definition of nuclear weapons or nuclear explosive devices. And in that definition, they exclude mechanisms for transporting such weapons as long as they are divisible. So the implication is that the use of nuclear propulsion for transport is not inherently non-peaceful. And it's one of those quirky differences then. And the other argument that was articulated when we were negotiating the quadripartite agreement with Argentina and Brazil is that given that their submarines are used for exclusively defense purposes, they are not considered to be non-peaceful. Interesting argument. The other point that I wanted to mention relates to something that Alexander mentioned on a number of with respect to a number of points, and that has to do with, can safeguards be applied to nuclear material while it is in these non-prescribed military nuclear activities? And the answer is yes. Clearly, the statute of the agency, Article 1, would preclude the use of any nuclear material or facility that was provided to a state with the assistance of the IAEA. It ensures that the agency applies its safeguards to ensure that no materials or facilities provided through agency assistance can be used for any military activities. That is not the case with respect to other types of safeguards. And there is no prohibition in the statute for the agency to apply safeguards measures to a non-prescribed military activity. Now, when you look at the language of paragraph 14, it talks about while the material is in that non-prohibited military nuclear activity, it says safeguards under this agreement will not be applied. That doesn't mean that other safeguards measures cannot be applied while the material is in that activity. And indeed, it wouldn't make much sense to have a situation where you create a black hole by simply saying, we are now working in a non-prescribed military activity. The agency has no ability to ensure that there's, let's say, no diversion backdoor created by virtue of this. So, and with respect to what kinds of activities would be covered by paragraph 14, most of the comprehensive safeguards agreements are very standardized and based on paragraph 14 of 153. Interestingly, when we negotiated the quadripartite agreement with Brazil and Argentina, we agreed on language that reads somewhat differently and much more explicitly. Their special procedures, which is what their title to the article corresponding to 14 is, it says it can be applied for nuclear propulsion or operation of any vehicle, including submarines and prototypes, or in such other non-prescribed nuclear activity as agreed between the state and the agency. So the idea is it was certainly generated by virtue of Brazil's interest in a nuclear naval propulsion program, but it also anticipates that in the future, possibly, there might be other non-prescribed activities for which special procedures might be useful. So that's all I have to add, and also happy to make myself available for questions. But thank you, Alexander. I think it was a very needed kind of presentation to step back and look at this as technical issues and really commiserate with all of the teams that are trying to negotiate these arrangements. And I mean on the agency side and on the state side. So thank you.
Thank you, Laura, very much for these very interesting and contextually needed inputs to what has already been a very interesting discussion. I'm happy to say that the questions are pouring in. Some are sort of more technical in nature, and I think that we start with those, given that that's what we came here to talk about today. The first one that I will ask you, Alexander, and then Laura, of course, if you have any inputs, you're more than welcome to chime in as well. It's from Adam Bernstein, who thanks both of you for the helpful overview and asks Alexander if you can elaborate on some of the proposed technical measures that you referred to that might permit monitoring of the reactor and or fuel on site from outside of the submarine. I know that you did a number of interviews on this particular question, so if you could sort of expand on that a little bit.
Yes, of course. Well, thank you first of all for the for that question. Now, these are mostly somewhat experimental um, methods. I'm not sure how many of them have actually been properly implemented, especially none of them, of course, to actual military submarines. But the main measure that has been suggested in the literature has been to measure the emission of certain small particles, I believe antineutrino measurements that escape through the reactor, the shielding through the hull, and that can be measured to deduce the power very vaguely of the reactor, and especially to deduce that there is indeed nuclear material present. So this means that you would have to set up your equipment, which I'm told is rather can be rather hefty depending on how precise you want your measurements to be, some distance from the submarine. But as far as I've understood it, it would actually be possible to do it from a distance that wouldn't necessarily cause classification concerns. It would be something that wouldn't reveal more to the IAEA than they could glean from simply looking at your Navy's media publications. But it would allow them to verify that yes, there is indeed nuclear material present on the submarine. I'm sorry, I'm not getting any audio for a second.
Just a moment. There we go. Apologies for that. Laura, did you want to add anything to that?
No, thank you. I think Alexander handled that quite well.
Fabulous. The next question that I think probably both of you would have inputs on is something that you spoke about a little bit, Laura, on the difference between peaceful and non-peaceful activities. Now, I recall in the negotiating history that this did come up. Do we need a definition of a military nuclear activity or a peaceful nuclear activity? Uh, so, Mike, you already touched on this a little bit, but my question to both of you, perhaps Alexander and then Laura, what is your view, Alexander, from the interviews that you did, and Laura, from your experience on the feasibility of coming up with a definition for a peaceful nuclear activity versus the value of attempting to do so in this context?
So I think the first point that's important to make is that that's not necessarily a new question. The exact same question actually came up during the negotiations of INFCIRC 153. I have a report that was written about the negotiations in the US, which also mentions things like a definition of peaceful nuclear activities being proposed by the UK, which was discussed. They describe it at some length, which I think is diplomat speak for it kept us up until 2 in the morning. And various countries really emphasized the need to have such a definition. I think the lack of definition, the fact that we're still talking about it, shows the difficulty in doing so. I think in general, we see that despite not having such a clear-cut definition, the IEA has been able to do its work quite well on the basis of what we do have, and it's quite clear in most cases when an Article 14 arrangement would apply. It's more about setting the boundary at a certain point, but it could be more appropriate to do that on a case-by-case basis rather than now getting one size fits all definition, which has been eluding us for many decades already.
I couldn't have said it better myself, Alexander. The reference to the discussions in the Committee 22 when they were talking about what became paragraph 14 are interesting and not at all conclusive on this issue. Do I think it's necessary? Probably not, because, as I said, there were discussions about, is a submarine that is simply used for defensive purposes considered non-peaceful? Differences of views about that. Again, is it necessary to resolve in order to implement safeguards or paragraph 14 or Article 14 in the agreements? I think not. It's clear that this provision is intended to relate to military activities. And if it is anything other than a military activity, comprehensive safeguards agreements attached to that material and to that activity.
Thanks both. And I also, I must say, found the discussion as to the definition of a peaceful activity to be as how did you phrase it, Alexander? Up until 2 in the morning. I can only imagine. Uh, Sort of along these same lines, we have another question asking about the difference between a civilian nuclear propulsion program and a military nuclear propulsion program. So the question as such is it realistic to imagine having a civilian nuclear propulsion sort of safeguards framework that works first and then adapt that to military cases? Perhaps I give that to the lawyer. But I'll take my sort of prerogative as moderator to then ask you, Alexander, in the research that you've done, technically speaking, do you see a difference between a civil and military propulsion program? So, Laura, perhaps you'd like to start?
Sure. Indeed, as I mentioned, back in the very early days, both Japan and Germany made an effort to use nuclear propulsion for civilian. One was a cargo ship, and I've forgotten what the other one is, but neither of these initiatives actually bore fruit, but they would have been subject to routine safeguards under a comprehensive safeguards agreement. And where you get stuck, so would it be a good idea if you had a civilian submarine, figured out how to safeguard that, and then apply it to a military program? That sounds like a great idea, but you're going to come up against some of the most classified information and I'm certain, regardless of what the parameters around what is classified and what is not might differ, but I know in the United States, some of the most sensitive military related information concerns nuclear naval submarines. And I would be surprised were that not the case in most other countries that have a military submarine program. So you're going to come up with classification issues. And paragraph 14 basically says the agency doesn't have a right to demand classified information. So ideally, great idea, but as a practical matter of implementation, I don't think it would work. I do think we are going to have to come up with interesting ways of applying safeguards to these novel uses of nuclear, whether it's in propulsion or in the space or whatever. So special procedures are going to have to be derived for special situations, but not because it's not routine safeguards.
Yeah, thank you, Laura, for that. I fully agree. I also think you already mentioned that previously in civil application, it's been looked at to use nuclear propulsion for cargo ships rather than civil or civilian submarines. There's also a good reason for that. It's because nuclear naval propulsion offers certain advantages in a military context that aren't as relevant in a civilian one. Things like being able to have a longer patrol time or being more silent or maneuverable in many cases. These are very important in a military context. They are very expensive to acquire as well. And they're not as relevant to civilian vessels. So it's less likely that we'd actually see civilian submarines, which means that we would be developing safeguards framework for a very different type of vessel. What's also important is that the classification isn't just about the sub. The classification is also about what operations is it carrying out. We don't, or states don't want to tell the IAEA, well, my submarine carrying important weaponry is right now conducting operations exactly in this location. Whereas in a civilian case, safeguards usually do need to confirm the actual location of the nuclear material. So those are two important points that I think mean that you couldn't develop the same type of safeguards for civilian as for military applications of nuclear naval propulsion.
Thanks, Alexander, and apologize that the quality of audio has now changed. I've been having a few problems with my microphone. Um, so I've tried to keep some the questions largely technical in nature, considering what we're talking about today is in fact the technical factors. We did receive one very interesting theoretical question that perhaps I'll ask Laura to address first, and then Alexander to respond to. Um, what would happen? What would the IAEA do? And the question specific to inspectors, but if the sub goes down but never comes back, so the individual Stepani Konkama, and I apologize if I've mispronounced your name, elaborates that the reasons may be very sensitive as to why the submarine went down, classified events, maybe they don't disclose it to the IAEA, including its location. So just theoretically, what do you think? What happens?
First of all, what a horrific scenario. Can't imagine being on that submarine. I don't know what's going on in the negotiations for the Article 14 arrangements, but perhaps even that is being discussed. What I would imagine as a practical matter is the IAEA would certainly be informed of that. I cannot imagine a scenario where that wouldn't be necessary. And I suspect that there would be mechanisms for verifying that it did indeed go down with the reactor on board. Um, Again, the scenario is horrific in and of itself. So I imagine it would be handled practically speaking. We have had serious nuclear accidents, and the agency has been able to work with countries on those to ensure that they didn't become a mechanism for diversion. So, for example, Fukushima. Also, although Ukraine was then part of the Soviet Union, there were mechanisms in place to make sure there wasn't a diversion of nuclear material at the facility there at Chernobyl. So I think it would be handled as a practical matter, and there would be some mechanism for ensuring that that submarine wasn't clandestinely retrieved and the reactor removed therefrom.
Thanks, Laura. Anything to add on that, Alexander?
Yeah, I would say 2 points. The first is that this isn't necessarily a theoretical scenario. Of course, we had the sinking of the Russian Kursk submarine that posed very similar challenges. In that case, of course, it belonged to a nuclear weapon state, and it sank relatively close to that nuclear weapon state, which might take away some of the concerns. But I think the most important question to ask is that throughout the discussion on Article 14 is if a state really wanted to divert nuclear material, is this how it would go about it? Would it produce a multi-billion dollar submarine, put nuclear material in it, negotiate for years and years, and then sink the thing and send a team to secretly extract the nuclear material? It is, of course, extremely important to recover that nuclear material, also to make sure that no third parties maybe have access to it. But I think that in this theoretical scenario, we are very almost guaranteed to have a lot of cooperation between the state and the IAEA to make sure that this retrieval occurs properly.
Great answer, Alexander. Great answer.
And I think you've already answered one of my sort of prepared questions, but I'll ask it anyway just to drive this point home. Do you see any scenario in which a state chooses to divert from a propulsion program rather than just having a clandestine program for the purpose of weapons development?
I would say there is a scenario. It's likely not the scenario that people are thinking of. I think the scenario that we should be most wary about is actually a change in policy after an Article 14 arrangement has been made. A state that changes its geopolitical priorities and decides, whereas before they were abiding by their NPT commitments, they decided afterwards, actually, there is an opportunity here to try to divert, to try to work this into a weapons program. In that case, however, it's important to know that an Article 14 arrangement, as Laura mentioned, doesn't mean no checks on the nuclear material. the IAEA is actually in a very strong negotiating position in these negotiations. If the IAEA isn't confident that there won't be any diversion, then they don't give their approval for the program. The state can't use their nuclear submarines. So any arrangement that the IAEA, with its decades of expertise and with its strong negotiation position, agrees to is very, very, very likely to meet any challenges that come up, even if such a change in policy in the state in question happens.
If I was to wish that our viewers today took any one thing away from our discussion, it would be that. Thank you. Well said, Alexander. Um, we've had two questions that I certainly don't know the answer to, but perhaps one of you does. With respect to the environmental impact of the use of nuclear fuel for naval propulsion. So one person is asking, generally speaking, about the impact itself of basically a reactor underwater. Another individual is asking about the waste disposal following the use in the submarine, what the implications of that might be, and is this different in any way than a normal waste handling? Perhaps we start, Alexander, with you if you have thoughts, and then we'll go to Laura if she'd like to follow up.
Yeah, sure. I think first of all, these questions are very interrelated because the environmental impact, it's important to know. There's no nuclear material being strewn around the ocean floor. We don't sail through the seas with our submarine and then chuck out a little bit of uranium halfway through. No, all the material is retrieved after refueling activities. It's disposed of normally. I'm not aware of very different disposal methods between this type of nuclear naval propulsion program and a normal civilian program. As far as I'm aware, if the type of material and the reactor is similar enough, the approaches to storage are essentially the same, or even to reprocessing. When it comes to the environmental impact during the operation, there is radiation that escapes through the top of the submarine. As I mentioned, there is less radiation shielding on the top of the submarine simply because there aren't any people on top of the submarine during its operation. They're off to the sides. So radiation does escape. I don't think that the impact, as far as I've seen, is gigantic. There's not swarms of fish dying anytime a submarine passes by because the exposure um, of any area in the sea is also very short. The submarine is on the move, and rather than being exposed for days on end, which would cause big radiation issues, that's not the case. So yes, there are environmental implications. As far as I know, they are not as big as we might imagine.
Thanks. Laura, did you have any follow-up thoughts on that?
Not with respect to the environmental impact of submarine or submarine nuclear naval propulsion, but the questioner raises a good point, and that has to do with how long does the agency track that material for purposes of ensuring that it's not diverted? And as long as the reactor core remains welded and it's trackable in some fashion or another. I imagine it would first of all have to be cooled, and then the fuel would have to be removed, and then depending on what they do about its disposition, it would either be reprocessed or it would simply be buried in a geological repository. And each one of those scenarios has its own challenges, not the least of which is the construct of that reactor and the fuel that remains in it. Do they retain their classified characteristics, which would impact whatever safeguards approaches would be used with respect to that material when it's removed from the submarine?
Interesting question indeed, and I would also like to amplify something that you said during your initial reactions, Laura, that different governments have very different views on what kinds of things are classified and what kinds of things are not classified. And this is something that is, you go into any nuclear related treaty that requires verification, and you will find in the negotiating history discussions about what kinds of material this applies to, and sometimes they even call it different things, depending on what it is that they're concerned about. But that is a rabbit hole I am not to go down right now. There's another question that both of you kind of touched on during your initial remarks, but it does, I think, bear repeating for those on the line. And that has to do with the prospect of nuclear submarines in undeclared facilities. This is something I think I've heard you refer to, Laura, in the past as the can opener approach, something that you, Alexander, referred to in your presentation as James Bond, something to that effect. But the full question is as follows. How likely is it that nuclear submarines could be handled at an undeclared facilities? For instance, could fuel be removed from the submarine at an undeclared facility without being spotted on satellite images? And what would be practically required to do so? So once again, why don't we start with you, Alexander, and then Laura, if you've got thoughts, I would welcome those as well.
Yeah. Yeah. So as I mentioned, yes, it's possible to build a military base outside of the view of satellites, of course. There are two important caveats to this. First of all, even if the base is hidden, its construction won't be. You need not only very heavy equipment to, for instance, build a base in a cave system, but also then you need all the equipment required to actually handle the nuclear material after you've extracted it covertly, which means that states will be able to see there's all this nuclear technology, all this nuclear related equipment going to a cave somewhere in this country, or that's simply unaccounted for. There's probably something strange going on there. There is also the fact that satellite imagery isn't the only or necessarily the most important way to tell that there are diversion activities going on. As I mentioned, there is human intelligence going on, and if a state concludes an Article 14 arrangement, that will raise suspicions, which means that states will increase their human and signal intelligence in the state in question. So it's very unlikely that will be entirely undetected. If you were to try to take this approach, you would not only need probably a very a big cave system or cliffs on the side of your coast, where you have a coastline that's deep enough that you also wouldn't be able to see the submarine enter your covert base on satellite imagery, because if the water is shallow enough, that's also something that will be spotted. You would need, as I mentioned, heavy equipment. And very importantly, you wouldn't only need this covert military base. You would also need covert nuclear facilities throughout your country. So I think this approach gives a very, very small potential benefit to being less detectable. And it gives a very, very large downside of being extremely expensive without it being worth it, so to say.
Thanks, Alexander. And Laura, before you react, I would also wonder your thoughts on the difference in the answer for this question between a state with only a comprehensive safeguards agreement versus a state with a comprehensive safeguards agreement and an additional protocol.
Okay, I'm going to start down a different track. First of all, would a state want to produce a clandestine nuclear-powered submarine program? It'd be really expensive and really difficult to hide. And nowadays, remote imagery is improving to the point where it may not always be possible for a submarine to hide in the ocean somewhere. Also, it's apart from being expensive, there are, dare I say, less dramatic ways of producing a nuclear fuel cycle and diverting nuclear material. But one thing we haven't touched on, and maybe this is a little bit James Bondy, what would have happened if there were a dramatic change in the government's regime that could, let me back up. One has to be careful about assuming whether something is practical or economical. It depends entirely on the diverter. There may be situations where you might not do it, but if you're highly motivated and you have the money, you might do it in a way that was no longer expected, as in the case of EMIS in Iraq. But the one scenario we haven't touched on is, what about a non-state actor hijacking a nuclear-powered submarine and removing the reactor? I imagine that would require much more than a James Bond scenario, but that would be a situation where you have a highly motivated non-state actor that in effect hijacks and steals the reactor. Again, even if they're able to do that, they would have to, if they wanted to retrieve the material, they would have to have a mechanism for reprocessing that. Now, they could also use it as a dirty weapon. I suppose my imagination is somewhat more limited in that regard, but that wouldn't be a question of a state decision, I don't think. I think it would be a terrorist activity. Your question was, does it make a difference whether a state has a CSA alone or a CSA and an additional protocol? The additional protocol obviously gives the agency a lot broader information about the state's nuclear fuel cycle. It requires the state to tell the agency its 10 years plan for a nuclear fuel cycle, and that would include the submarine activities. So the agency would be informed well in advance before that would to get underway. That is not the case in a state without an additional protocol. And of course, there's much broader access in a state that has a CSA and an additional protocol. So there would be differences in terms of the agency's right for access and information.
Thanks to you both. So we're coming towards the end of our time, and so what I think I'll do is I'll ask one more question from our audience, and this will be to Alexander, and then I have a closing question for both of you. The last question from our audience refers to the difference between HEU and LEU fuel for the reactors. Now, you've already touched upon what that would mean for refueling times, but the question is, in your research, have you found practical differences between LEU and HEU fueled reactors other than the refueling time? They go faster, anything to that effect?
I think an important thing, I don't necessarily recall them being able to go faster or quicker, at least that, as far as I'm aware, doesn't depend on the HEU or LEU. There are some other advantages, like being able to have the same core lifetime with a smaller amount of HEU, which could let you build a smaller reactor and thereby that giving you advantages like a lighter or in that way perhaps faster submarine. But I think any advantages that HEU or LEU give you isn't inherent in the choice between the degree of enrichment. It's mostly about what are its other effects. Does it make the reactor smaller? Does it, for instance, allow you to use, well, different types of coolant? But as far as I found, really the question is LEU forces you to refuel more frequently than HEU, and that is the motivation for countries to choose one or the other, not necessarily the exact operational characteristics.
Thanks, Alexander. So my closing question is we'll start with Laura, and then we'll end on with Alexander. With Laura, we had one audience question. How do you see this issue playing out in the IAEA? But I'd rather ask you, how would you prefer that this play out in the IAEA policymaking organ, this discussion of Article 14 arrangements and so on? And then to Alexander, to give you a moment to sort of think about it. We did have several people ask if this research will be published, and I want to just tell everyone right now that there is a shorter article with the European Leadership Network that is published that you can find on our website. Alexander has written an extensive report on his findings that will be online as soon as somebody has time to publish it. So we'll get there. So don't worry about that. But while Laura is answering her question, Alexander, think about what your biggest takeaway from this research has been for you. What's the line that you wish everyone would remember after everyone gets off the call today? So Laura, please go ahead.
Here's what I hope, that the agency and the states concerned are able to negotiate a watertight, if you'll pardon the expression, arrangement or arrangements, and that there is some clarity as this develops as to what are some of the guidelines, the guardrails, if you will, around these types of arrangements. I would hope that as much detail as is possible, respecting the sensitivity of the information, would be shared with the member states and the policy-making organs, and that they will go to the board. The Director General has already said that. The big question is, should the board insist on being able to approve the individual arrangements? I think the board has the authority to decide what it wants to do. At a minimum, they would be asked to take note of it. There may be some value in actually the board approving those, so that that the board exercise some oversight. But again, there will be constraints on what the Secretariat will be able to share. But I would encourage all parties concerned to consult as much as possible, as frequently as possible, with as much information and transparency as is possible in that context.
Excellent advice, all. Thank you, Laura. Alexander, the last word is to you.
Yeah, thank you very much. Well, first of all, I'd say to anybody attending, apart from reading my piece, also read the ones published by Noah and Laura that are also on the VCDNP website, which were also incredibly helpful to me myself when I started this research. And if I had to give one key takeaway, I would say that we shouldn't focus too much on diversion when nuclear material is in the submarine. And we really have to look at the application of routine safeguards and other verification measures during the fuel cycle. So rather than hammering on, can we take nuclear material out of the submarine in a hidden cave somewhere that we've constructed because we want to divert, focus on questions like there is highly enriched uranium in these fuel fabrication facilities. Are we checking what's going on there with routine safeguards or with verification measures? And if we're doing them with different verification measures, what measures are we putting in place exactly through this arrangement? Because that is really where the main concern, as far as I see it, with an Article 14 arrangement would lie.
Thank you, Alexander, and an excellent note to end on. Thank you both for a very engaging hour and 15 minutes on a subject that I think is not going anywhere. I think it has been an insightful discussion, and to all of our viewers, I wish you a wonderful rest of the week and a lovely weekend. Thank you so much.
Thank you.
Thank you.